Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 713, subarray product less than k. This is a medium difficulty Leetcode problem, and the problem description tells us that given an array of integers nums and an integer k, we want to return the number of contiguous subarrays where the product of all the elements in the subarray is strictly less than k. And so we're given an example here where we have 8 subarrays that have a product less than 100, so k is 100, and all the subarrays where the product, where if you were to, the product of all the elements in a subarray, if you were to measure them against k, they would be less than k, and so we return 8, which is the number of subarrays that have a product less than 100. So we can see we have 10, 5, 2, 6, 10, 5, 5, 2, 2, 6, 5, 2, 6, and so it can be a bit hard to spot, but this is a classic sliding window problem, and we basically want to solve this problem using a sliding window. So what will we add to our result variable? So we're going to have a result variable. Initially, we'll set that to 0. And as we're going through our subarray, we will check, is 10 less than 100? Well, yes, it is. So let's increment our result by 1. So we'll increment that by 1. Then we look at 10 times by 5. That's 50. 50 less than 100? Yes. Yes, it is. Then we look at 10 times by 5, which is 50. And then times that by 2 gives us 100. Is that less than 100? No, it's not. So what we want to do is shift our left point of our window and now check for 5 and 2. But hey, wait a minute. If we skip and we only look at 5 and 2 now, well, we're skipping 5. We're skipping 5 because we looked at 10. We've added 10. We've added 10 and 2. But 10 and 5. But we've added 5 and 2. But we haven't added 5 on its own. So what we want to add to our result is the length of our sliding window. So the right pointer minus the left pointer plus 1. That's what we want to add to our result, and that will factor in not just the subarray length, but also the subarrays contained within that subarray. So in this example, we would get 5 and 2, but we would also get 5 on its, we get 2 on its own. So in this case, for example, we have 10 and 5, we have 10 and 5, which is one subarray, and then 5 on its own, which is another subarray. So I hope that makes sense, and it basically considers the fact that we have, each element on its own is also a subarray. So let's actually get to coding this problem, the solution for this problem. So the first thing we want to do is have a result variable. We'll set that to 0. We'll have a left variable set to 0 as well, and we'll have a product. And normally with any sliding window problem like this, our product will be 0 if we were incrementing, but multiplying anything just by 0 is just going to give us 0. So we want to have this initialized at 1. And then we want to say for, let's go through the length of nums, and this will be how we increment our right pointer. And we're going to update our product times equals nums r, so the number at the right pointer. And when do we want to shift our left pointer? Well, we want to shift our left pointer while the product is greater than or equal to k. Well, we want to say let's increment our left pointer, and let's also update the product. So let's remove the number at the left pointer once we do that. So product divided by the number at the left pointer. And you may think, well, the left pointer will never go past the right pointer, but that's not true. There are edge cases, and one of those edge cases is where k is equal to 0, and we'll just keep on going. We don't want that to happen. So we want to add a quick little guard check here while the left pointer is less than or equal to the right pointer and the product is greater than or equal to k. What do we want to do after that? Well, we want to update our result variable. So we want to increment it by the length or the size of our sliding window. So we want to say L minus R, or R minus L, sorry, R minus L plus 1. So that's going to add all the subarrays which have a product less than k, or the length or the number of those subarrays, and then we want to simply return the result once we've finished from our for loop. So let's submit our code and let's check that our solution actually passes all test cases, and it does. We see that we passed all 98 test cases for this problem. So in terms of time complexity, it's going to be a linear time complexity. So it's a big O of n time complexity, and the space complexity for this problem is going to be big O of 1. And with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.